Hi, and welcome to this video. Today I'll be talking about flattening a multi-level doubly linked list. So here we see a doubly linked list. We are given a doubly linked list in addition to the next and the previous pointer. We have the child pointer right here. This child pointer may or may not point to a separate doubly linked list. So in this case, there is nothing pointed here, but here it actually points to another doubly linked list. These child lists may have one or more children of their own. So here we see this one, number 8, actually has another child list in it. So these child lists produce a multi-level data structure as shown in this example here. The goal is to flatten this list so that all the nodes appear in a single level doubly linked list. You are given the head of the first level of the list. So here we see the output, how the output should look like. So we got 1, 2, 3, and then it jumps down to 7, 8, and then it jumps down to 11, 12, and then it goes up again to 9, 10, and then it goes back up to 4, 5, 6. So if we were to imagine this, it goes this way, down this way, and back up here. So then it will look like a flattened doubly linked list. So let's start with writing the code. We're going to call it flatten, and as the question said, they're going to give you you're given the head of the first level. So you are given this one, so your head is here. Excuse me. So let's start by assigning the head to a variable called node, which is n. So our n will be here. And basically, while node, which basically means while there is a value, if there is a value, it's not empty, then what I want you to do is I want you to check if there's a not child. And it's a simple check by looking at this child here. If the child has something, does it have something? No. Does it have something? Yes, it has something. Then you want to go to the next level. If this node doesn't have a child, then basically assign the node to the next one. So basically you want to keep on iterating if there is nothing. So node next, go to next, go to the next, until you eventually find a child. Whether you do find a child or not, I want you to return the head, where the head in this case will have the head node, and all of the .next should contain it in a single linked list. So I always like to establish the foundation of the code on having these problems so you can begin to see the common sense here, and then we can start filling out the rest. I hope this is just a basic idea to actually start solving this problem. Okay, so the node is here and it's checking. So here it's gonna go next, and then it's like, oh, we got another node, check next. And then all of a sudden it finds out that there is a child here. Well, if it finds a child here, then we want to save the next so we can link the tail of the flattened child list. So what does that mean? We're going to create a temporary variable, and call that old_next. So on the node that you have find the child, I want you to save all of this here as old.next. Right, so now we have this saved in this variable, old_next. Next, we want to assign the node.next. So we are here right now. So we would like that the node.next to be this right here. So in our case, we're going to say the node.child. So we would like the node.next to, instead of pointing to the here, I want you to point it to the node.child. So effectively, this is what we're doing. So we went here, number 3, and now instead of having number 3 point to number 4, we would like number 3 to point to 7. So this is what we achieve with this code is this link right here. Next, we want to do that the node.next.priv should equal to the actual node. So if you were to imagine that, so this is the node.next.priv should equal to the node. So then we have created this reverse connection here. One more time, we have iterated through this until we found the child. We connected the node.next to the node.child, and then we said that the node.next.priv is pointing to this node. So now we have created this link here, and then we say node.child equal none, which basically means that we're severing this tie here. We're saying that the node.child is gone. This is now gone because we have moved it as the new next here. Okay, so we have now, with this piece of code, we have canceled this link here. Now, while node.next, so while node.next, actually, so if there is more connections here, I want you to keep on iterating. Node equal node.next. So keep on iterating until we get to the end of the list. So you go on here, and then you go on here and here. But hold on a second. What if one of our child nodes has a child node? So what do we do in this case? We can simply do recursion on this right here by passing the node child back into this function. So let's imagine how this happens. We'll come here again. So once we've found the child, which is in this case, it's right here, I want to assign the node.next to this node.child. So we want to assign the node.next to the node.child. But hold on a second. We have this self.flatten. So what it will do is actually pass all of this again back into our function here. So the new head will be this node. And if node.child, so again, it's going to start iterating. Hey, while node, is there a child here? No. Okay, go to the next one. Hey, is there a child right here? Oh yeah, there is actually a child right here. So it's going to go down one more level, which we actually see in this case 7, 8, and then 11. It doesn't actually continue to 9. It goes to 11. So what this does here is that the node.next in this case, which will be 8, the node.next will be this node.child, and then the node.next.priv will point back here. So it's the same principle as before, but it goes down a level. And then we sever this connection by saying that the node.child is now gone, and this has been actually transferred here. So we kind of repeated the same thing. Now we will continue iterating, but let's do it at a lower level. While node.next, the new node will be the node.next. So this is node here, which was the head. Well, hey, there is another one going on. So yeah, sure, move it to the next one. Okay, and if you're finished, if there is actually no more, which is in this case, this is going to be false here when the node is placed here. What I want you to do is that the node.next will equal the old underscore next. Wait a second. Where did we get this old.next from? The old.next in this case is the older node.next. So in our case, it was this that was saved here. So in this case, it would have been this one. So the node.next, after you have reached the last one, 12 is going to go back and connect the 9 and 10. So if we take a look here, it's 9 and 10. And then when it exits and comes back here, this 9 and 10 will be connected back to the 4, which is 5, 6, as we see down here. Now, in this case, it will connect this back to here, and then it will look at number 9, and you would just say if old.underscore next. So if it just happens that there is a value there, then I want you to make sure to build also the priv, which is, if we take a look, let's clean this bit a little bit up here. So if we take a look at number 12 here, the priv, sorry, look at number 9 here, the priv pointed at 8, you are just modifying it so the priv actually points at 12. So by saying that if old next exists and it has a value, I want you to point the previous of that into the current node, which you have iterated through in this case. And then we simply, and if I delete it, yeah, just clear the space, then node.node.next, node equal node.next. In this case, if it didn't find a child and you want to return the head, and when you return the head, it's going to give all of this here. If we run this here, we see that our submission has used 100% less memory than all the submissions here, and it's 30% faster than the rest. The time complexity of this is ON because we have to iterate through every single one of the nodes here, and our space complexity is also ON because while we're running through these processes, we actually have to create a new variable called old underscore next, and we have to store all these variables as we go along. This is, of course, in the worst case scenario. Thank you.